Good morning, one and all. In the last lecture, we have solved the numerical on Newton Raphson method. If we have given two initial guesses, then how to solve the given numerical. But guys, sometimes what happen? They are mentioned use the convergence method. Okay, convergence method or divergence method. Exactly what is mean by convergence and what is mean by divergence, we'll see in the details. In the Newton Raphson method, the root is estimated by draw a tangent. Okay, we have seen the theory of the Newton Raphson method. Okay, how to find out that root? We are draw the tangent at a point y1. Okay, whose coordinate of that point x1 y1. Okay, and we want to find out the actual root with the help of Newton Raphson method. Okay, Newton Raphson method. In this convergence, see actually what happened, the tangent, when you draw this tangent, is intersect at the x-axis at a point which is represent the root of the curve y is equal to fx. Okay, and you draw the tangent to the given slope, and this tangent is intersect at a point which represent the root of the curve, and the curve is y is equal to f of x. If you have seen in this figure, then see the path 1 to 4 shows that with Newton Raphson method we are approaching towards the actual root. Where is actual root? Here is actual root. First we will get the first equation. When you draw the tangent to the y1 point or this slope, then you will get the second one. Again we will draw the tangent to this curve, then you will get the different value x1, x2, x3 respected to y1, y2, y3, and we are going to the close to the actual root. Hence, this method convergence occurs in this case. Okay, convergence occurs in this case. The value of root x2 can be calculated with the help of this formula. x2 is equal to x1 minus f of x1 divided by f dash of x1. Already we have seen in this formula the Newton Raphson method. Okay, but here is a one condition is given. If you are not given the initial guess, okay, then you have to assume the initial guess. Once you have assumed that initial guess, then you have to check whether the initial guess are right or wrong. Okay, then how to check that initial guess are right or wrong? You have to use this formula, mod of f of x1 into f double dash of x1 into bracket f dash of x1 bracket close bracket square is less than 1. Use this formula. If this condition is satisfied, then your initial assumption guess are right. Okay, your initial assumption guess is right, otherwise wrong. Okay, all of you getting how to calculate that value f double dash of x1 or f dash of x1? We know that. Okay, if you know the given function f of x, suppose this is the given function f of x is to x cos x minus 1.2 is equal to 0. This is the given function. Then you have to differentiate that given function with respect to x. Then you will get the f dash of x. and again if you have differentiate that f dash of x value or equation, then you will get the f double dash of x. Clear? What is the convergence? They are clearly mentioned in the problem statement. Solve this problem with the convergence. Okay, Newton Raphson method, convergence. Okay, second is see, in this case we are going, actually we are approaching towards the actual root, that's why this method is known as a convergence method. Then second is a divergence method. Already we have seen, we are in this slope, if you have seen y versus x, okay, this slope I have drawn here, okay, this slope, check that this slope, actually what happened, we are who's moving the closer to the root, if you have seen the path, okay, if you have seen the path of that root, here is the first x1 moving to the y1, then when we draw the tangent, this tangent is intersect to the x-axis, okay, but root is here and we are moving towards the away from the root, that's why this method is called as a divergence method. We are actually moving always from the root as the slope of the curve is greater than 1. Here is the slope of the curve is less than 1. But in this case, the slope of the curve is greater than 1. That's why this method occurs in the divergence case. Okay. Then how to find out the initial guess value? You have to check that f of x1 into f double dash of x1 divided by f dash of x1 square greater than 1. Only here is a less than 1 and here is a greater than 1. All of you getting what is the convergence or divergence method? In Newton Raphson method, if they are not mentioned, the convergence or divergence, then you have to use the regular method. We have seen two numericals already. But if you have mentioned their convergence method or guess is not given, okay, initial guess is not given, then you have to check with the help of this formula, initial guess whether right or wrong. Okay, we will see the one example here. See, I will explain that example. 1 minute. Okay, then we will see the one example. If you have not given initial case, then how to solve that example? See, what is the given? Find a real root of the equation. Equation is given. I will write here fx is equal to e raised to x cos x minus 1.2 is equal to 0. By the another method means what? Newton Raphson method. Correct to the 3 decimal places. Means they have given the accuracy. Accuracy has given 0.001 is there. Okay. We want to check the accuracy or correct up to the 3 decimal place. Step, how do you select the initial value of x? We want to step how the choose the initial value of x. Okay, here first we want to assuming initial guess, I will assume x0 is equal to 0. I will assume here initial guess start from the 0. Okay, once you assume the initial guess x0 is equal to 0, we know the formula how to calculate f of x0 into f double dash of x0 divided by f dash of x0 bracket square. this we want to check the less than or 1 or not. Before going on that, we want to calculate. Suppose this is the equation number 1. I will give the equation number 1. Then again, what we require? F dash of x. Okay, here I will write the step number 1. Okay, you can remember the steps also. If you easily you can solve that given example. F of x. Okay, in the step number 1 we require the f dash of x. So what I will do here, differentiate equation 1 with respect to x. Then we get, what we get? See, equation 2 will get f dash of x is equal to that e raised to x, okay, into cos x. You know, you have already done in the mathematics subject how to calculate the, when you differentiate equation, that equation with respect to x, how to calculate the derivative. E raised to x into cos x. I will write e raised to x into cos x plus, okay, plus e raised to x. What is the derivative of cos x? Minus sin x. Minus sin x. And what is the derivative of that constant? Is 0. Is 0. Then if you solve this, then see, I will take the e raised to x common. E raised to x into cos x minus what? Sin x. Okay, this is the f dash of x. I will write equation number 2. Equation number 2. All of you getting? In the step number 1, you have to differentiate equation number 1. Then you will get the equation number 2. In the step number 2, what will require? What required? Again we require the f double dash of x. How to get the f double dash of x? If you have taken the derivative of the equation number 2, again I will write differentiate equation number 2 with respect to what? With respect to what? X. Then we get what we get? Yes, f double dash of x. F double dash of x is equal to, check that, how to solve this? A raised to x into cos x minus sin x, right? This is the, we want to calculate the derivative. How to calculate? A raised to x into cos x minus sin x plus a raised to x as it is. What is the derivative of cos x minus sin x? Okay, and what is the derivative of sin x? Is cos x. Cos x. Okay. When you differentiate equation 2 with respect to x, then we will get this equation. Again, you can simplify that equation. We will take the e raised to x is common. Then check that cos x minus sin x. Then minus sin x minus cos x. Check that, huh? This minus cos x minus plus cos x get cancelled, and you will get this equation. I will take this minus 2 outside, minus sin x and minus sin x, you will get the minus 2. Minus 2 sin x. Minus 2 into e raised to x sin x. This is the f double dash of x. Okay, this equation number 3. Equation number 3. Okay, once you have got the equation number 3, then next step number 3. Step number 3. Whether you have to check the initial, I will write here, whether to check initial assuming guess right or wrong. Right or wrong. Okay, you have to check the initial assumption guess is right or wrong. How to check that? We know the formula. Use the, we have seen the convergence method. Okay, use that convergence method. F of x0 into f double dash of x0 divided by f dash to x0 bracket square less than 1. Okay, you have to put the all the value in that equation. Okay, from equation directly I will write here from equation 1. From equation 1, check that what is the equation number 1. From equation 1, f of x0 is equal to, you have to put x is equal to 0, then I will write f of x0 is equal to, or we can write the f of 0. x0 value, what is the assumption? x0 is equal to 0. Okay, here we have assumed that x0 is equal to 0. Okay, we want to then check that assumption. Here I have written x0 is equal to 0. We'll put x0 is equal to 0, e raised to 0 into cos 0 minus 1.2. Then how much you will get? The 0.2. Okay, check that. You will get the 0.2. Okay, sometimes in book you have written 0.2, again they are written 000. Means meaning is same, but up to the 3 decimal they have taken that value, or more decimal, 4 or 5 decimal. Then from equation 2, again from equation 2, check that we'll get the f dash of x0 or f dash of 0 is equal to, f dash of 0 is equal to e raised to 0, then cos 0 minus sin 0. Okay, you know that what is the value of that cos 0 is nothing but the 1. Okay, if 0 again 1, then sin 0, you will get the 1 value. And finally, from equation number 3, what will get? F double dash of x0 is equal to f double dash of 0 is equal to, what is the equation number 3? Minus 2 into e raised to 0 into sin 0, means you will get the 0. Okay, you will get the 0. Once you have calculated all the value in the step number 3, then you have to check our initial assumption guess are right or wrong. I will put all this value in this equation. Check that in this equation. What is f of x0? 0.2 is, sorry, here we have write minus 0.2 is there, because 1 and minus 1.2, we will get the minus 0.2. Then I will write in that equation minus 0.2 into what is the value of f double dash of x? 0 is there, 0, divided by f dash of x0 is 1. Then check that what is this? 0 divided by 1, you will get the 0. 0 is less than 1. Okay, means we can write our assumption is right, or our initial assumption guess is right. Okay, all of you getting up to this? These steps are very important. If you have not given the initial guess, then after that I will solve up to the equation number 1. Then you have to solve. Okay, you have to make the table and write down the answers. We'll see. Okay, then after step number 3, there will be iteration number 1 will start. Means again I will write the step number 4. There is a iteration number 1. Yesterday we have seen in the Newton Raphson method. Okay, we have checked that formula. Okay, which formula? x1 is equal to, we want to calculate the next approximation root. Okay, how to calculate that next approximation root using Newton Raphson Method. x1 is equal to x0 minus f of x0 divided by f dash of x0. Okay, in the step number 4 you have to calculate x1 is equal to x0 minus f of x0 divided by f dash of x0. Already we have calculated that value. Put that value in that equation, you will get the x1 value. What is the x0? We are assuming the 0 minus f of x0 we have calculated here, minus 0.2 is there, minus 0.2 is there, and what is the f dash of x0? This is the 1. This is the 1. Then what is the value of x1? What is the value of x1? You will get this minus minus get plus. You will get the 0.2 is there. 0.2 is there. Okay, check that. x1 is equal to 0.2 is there. Then next step you have to check that. Step number 5. In initial stages we have seen, we want to check whether our getting value is less than accuracy or not, or greater than accuracy or not. Okay, we'll get the accurate value. Here is a, what is this? Mod of x1 minus x0 is less than accuracy. Okay, if you have given the accuracy up to the 3 decimal, then we have choose value 0.001 is our accuracy. Okay, we have to check the given getting value is accurate or not. Otherwise, we want to replace that x1 value with x2. x1 value with x2. Okay, in the next step, x1, what is the value of x1? 0.2. What is the value of x0? 0. Okay, what is the accuracy? 0.001 is there. Check that 0.2 is greater than 0.001. If this condition is not satisfied, then you have to replace in step number 6, replace that x1 by x2. Okay, if this condition is here we have taken the x0 is replaced by the x1. Okay, and repeat that steps. All of you getting, replace that x0 by x1. Okay, and replace x1 by x2. Replace x1 by x2. Then next replace x2 by x3. Then we will see in the table. I will make here directly table. I have solved up to the first equation. Okay. Then you have to calculate the second, third, fourth equation. Whatever may be up to the accuracy. If you are not till getting the accuracy. In tables I will mention here iteration number 1. Okay, first I will make the table iteration number. After that we have calculate assuming value x0. Then after that we have find out the f of x0. Then f dash of x0. Then we have find out the f dash of x0. After that x1. Okay, or if you have considered the initial assumption value is x1, then here you will get the x2. Remember that you can change that variable. Okay, if you have considered the initial assumption value is x1, then here you will get the x2. Okay, all of you getting? Then finally we will get the accuracy. First iteration, what is the assumption value? x0, 0 is there. What is the f of x0? We have calculated that. F of x0 is equal to minus 0.2. What is the f dash of x0? This is the 1. What is the x1 value? 0.2 in the first iteration. And what is the accuracy again? We have the 0.2 is there. Very simple. Okay. Then next step, what is this step? Replace this x0 by x1. x0 by x1. What is the x1 value? 0.2. We are replacing that 0.2. Then what is the f of x0? We have to put this value again that equation. x2 is equal to f of x0 value. We have calculated in the equation number 2. When you calculate the equation number 2, then you will get the 0.00294 is there. Okay, positive value. Then again you have to put this value in the equation number 3. Equation number 3 to find out the f dash of x0. Okay, we are getting that 3 equations. Yes, all of you know that 3 equations. Then put this value in this, then you will get the 0.9544. Okay, and what is the value of x1? Here you will get the x2. Once you have got these two values, then you will get this formula: x2 is equal to x1 minus f of x1 divided by f dash of x1. If you are putting these 3 values in that equation, then you will get the next value 0.2030. Okay, 0.2030. And what is the accuracy? 0.0308 is there. 8 is there. Okay, how to calculate the accuracy? With the help of step number 5. Again here you will get the x2 minus x1 is less than accuracy. If you have calculated that x2 minus x1, then again you will get the 0.0308 is there. Okay, and third, how to calculate the third iteration? Again that x2 is replaced by the x1. x2 is replaced by the x1. What is the value of 2? This one 308 is here. 0.20308 is there. Okay. Then after that you have to calculate the f of x0 using the equation number 1. When you put this value in that equation 1, then you will get 0.0005 times 0, 2. Okay. When you put this value in the equation number 2, then you will get the 0.952890. Okay. Then after that, when you put all this value in that equation, x3 is equal to x2 minus f of x2 divided by f dash of x2. When you calculate, then you will get here 0.20308 is there, and you will get the accuracy 0.0064 times 0. Then check that these two values x1 and x2 and x3 value. Here check that we want to calculate the accuracy up to the 3 decimal point. Here it is 0.20308. Here is also 0.20308. Means we will stop the iteration here. Okay, and our root, exact root is, okay, root is 0.203 is there up to the 3 decimal point. Okay, the actual root is x3 is equal to 0.203 or x is equal to, we can say. Okay, how are you getting? If you are not given the assumption initial guess, then you have to assume and check with the help of this formula, convergence formula. Okay, today we will stop here.